Over the years, I've taught a lot of Calculus 1, 2, and 3 classes, and by far, probably the single most lacking skill that students have when they come into Calc 1 or Calc 2 or 3 is most students don't know the unit circle as well as they need to. Now, not all of this is the student's fault. A lot of instructors don't really emphasize memorizing the unit circle. A lot of instructors will allow like a cheat sheet on a test or a note card or just provide the unit circle on the test. But if you've taught calculus or you regularly teach Calculus 1, then you'll definitely understand the importance of knowing the entire unit circle and having it memorized. Now, it's a big task, so students usually don't want to go back and try to memorize it after they left pre-calc, but it's just so important. We use it so often in calculus that it's just really important. So in this video, I'm just going to try to give some tips on how to memorize the unit circle. In the video before this one, I explained what the unit circle is, so I'm just going to jump right into it. Just as a motivating example, I had an example like this the other day in class, and I just want to show you that without knowing the unit circle, it would have been difficult to solve this. This was some equation that equaled 0, and we had wound up factoring it, and so we set each of the individual factors to 0, and then we ended up with the two equations, sine t equals 0 and cosine t equals a half. Now, to solve this, you would have to think about what t values, if you took sine of it, would give you 0, and what t values, if you took cosine of it, would give you a half. And so just knowing the unit circle, you could just rattle off what those t values were. But if you didn't know the unit circle, you'd be fumbling with your calculator, and you still would not find all the values of t without knowing the unit circle. So just using that as a little bit of motivation, here it is. Here's the unit circle. You've got all these different radian angles on the inside. You also have the degree measures provided for you as well. And then along the outside, you have the x, y points along the unit circle. So we're going to separate these into two pieces or two chunks. I'm going to talk about how do you memorize the angles in the unit circle, and then we'll talk about how do you memorize the points in the unit circle. So here we go, starting with angles. We all, at least at this point, know that a full circle is 360 degrees, or you can say 2 pi radians. Those are equivalent. So we start by measuring the angle from the positive x-axis, that's 0, and as this opens up, you'll get a larger and larger angle, and a full revolution is 2 pi. That's equivalent to 360 degrees, 2 pi radians. So just based off of that, we can get the other axis radian values very easily. Halfway around the circle would clearly just be pi. If all the way around is 2 pi, halfway around would simply be pi. Now, 90 degrees, half of 180 or half of pi would be pi over 2. And then 3/4 of the way, pi over 2, pi, this would have to be 3 pi over 2. That's 3/4 of the way around. So those are pretty easy to remember. All right, now the patterns for the other angles that are in the middle of the 4 quadrants, they follow a pattern. They all have a pattern of just their denominators. We'll look at numerators in a second, of 6, 4, 3, period. It will never be anything other than 6 or 4 or 3 on the typical unit circle, and it'll go 6, 4, 3 as you move away from the x-axis. So this will go 6, 4, 3. This will go 6, 4, 3. You see, as you move up towards the y-axis, this denominator will be 6, 4, 3 and 6, 4, 3. So that's a good pattern there, that you move away from the x-axis vertically, or vertically up or vertically down, with the pattern of 6, 4, 3 in the denominator. All right, now how do we remember the numerators? Well, I've broken it up by quadrant. First of all, I'll say all the quadrants, all 4 quadrants, every radian angle has a pi in it. Now let's talk about the first quadrant. The numerators are all 1. So you would have 1 pi over 6, combining what we know from the last remark, pi over 4, and pi over 3. So 6, 4, 3, where the numerators are all 1. In the second quadrant, it's 1 less than the denominator. And there's a reason for that, and I'll try not to keep explaining where all this stuff is coming from. But if this is pi, then if you call that 6 pi over 6, and you back up pi over 6, which is this slice of 30 degrees or whatnot, and you would be here, then that would make it not 6 pi over 6, but 5 pi over 6. So that same logic would apply in calling this 3 pi over 4 or 2 pi over 3. Just simply remember it's 1 less than whatever your denominator is. 5 pi over 6, 3 pi over 4, 2 pi over 3. In the same way, the third quadrant is 1 more than the denominator. You're adding 30, 45, and 60 degrees to 180. So you would get 7 pi over 6, 5 pi over 4, and 4 pi over 3. Okay. Now the last quadrant, the fourth quadrant, this is the strange one out of the bunch. There's different ways to memorize this. The one I've kind of settled on is it's twice the denominator minus 1. Now somebody might give you another way of memorizing that, and there's a dozen different ways of remembering this fourth quadrant. But this denominator of 6, I would put 11 pi over 6. Now, why is it 11 pi over 6? Well, 2 times 6 is 12, minus 1 makes 11. If you want another way of remembering it, basically you're backing up pi over 6 downwards from 2 pi. So if you take 12 pi over 6, that's 2 pi, then you would have 11 pi over 6. Right? Likewise, this would be 7 pi over 4. That's pi over 4 less than 8 pi over 4. And then this angle right here would be 5 pi over 3. So I hope none of that's hidden behind my picture-in-picture. So there it is if you can't see it there. So that's the last of the radian angles. So that's it. Here's a completed unit circle, and we can just check it out real quick. I'll just highlight these in red right here. You have 0 and 2 pi. You have your axes angles, pi and pi over 2 and 3 pi over 2. And then you have all the ones in the middle, pi over 6, pi over 4, pi over 3. That's numerators of 1. Here's 2 pi over 3, 3 pi over 4, 5 pi over 6. That's numerator is 1 less than the denominator. 7 pi over 6, 5 pi over 4, 4 pi over 3. Those numerators are 1 more than the denominator. And then these kind of funky ones here at the end, 11 pi over 6, 7 pi over 4, and 5 pi over 3. So that you're halfway done. That's the radian angles. Now, are you going to get that in 6 minutes? Probably not. You probably need to practice that a little bit. But just using those tips I gave you, hopefully that'll get you by. Now, do you also need to know the degree measures? It's nice. It's a bonus for sure. But the most commonly used angle measure in calculus by far is radians. So I would spend most of my time memorizing the radian angles. All right, now on to the points. How do you remember what the points are? Well, let's look through all the possible x, y points you could get for any radian angle. Here they are. You see them all listed here, and you notice there's lots of patterns, lots of terms used over and over again. I see 0, I see a half, I see root 2 over 2, and I see root 3 over 2, and I see 1, and I don't see any other values. So you basically get the terms 0, a half, root 2 over 2, root 3 over 2, and 1, maybe positive, maybe negative. We'll deal with those later. But that's the x and the y values that you get. Now, where are all these guys occurring? Well, let's just go through these one at a time. The axes, those are pretty easy. Those are 1, 0, 0, 1, negative 1, 0, 0, negative 1. So those are pretty easy to remember. I'm not going to spend too much time on those. Now, the 45-degree type angles. Now, what do I mean by that? For those, I mean either 45 degrees or any symmetrical angle in any of the 4 quadrants. Because it's 45 degrees, the x and the y values will be the same. They have to match if it's along that line y equals x or y equals negative x. So these will always be the root 2 over 2 numbers and nothing else. If we cheat a little bit and go back up to the completed unit circle, you see root 2 over 2, root 2 over 2, negative root 2 over 2, root 2 over 2, etc., etc. They're always the root 2 over 2 numbers. So just associate those with the pi over 4 45-degree type angles. Now, number 4, ignore the pluses and minuses, because if you try to straight up memorize every sign, positive and negative, along with the numerical value, it gets quite intimidating. But if you just think about what quadrant it's in, that makes things a whole lot easier. That way you just have to memorize half as many terms. So for instance, look at the first quadrant numbers. Do you see how all the points are positive x and positive y? It's because it's in the first quadrant. Anything in the first quadrant has positive x's and y's. The second quadrant has all negative x's and all positive y's. The third quadrant has negative x's and negative y's. And the fourth quadrant has positive x's and negative y's. So think about the signs last. So ignore the pluses and minuses at first. They are important. I'm definitely not saying they're not important, but they're best considered towards the end of giving your final answer. Okay. All right. Now, probably the trickiest of all is these off angles, not the axes angles, not the 45-degree angles, but the ones that are mirror images of 30 degrees or 60 degrees. This will be pi over 6 and this will be pi over 3. So we take these numbers that would possibly be any of our results, 0, a half, root 2 over 2, root 3 over 2, or 1. I went ahead and marked out all the ones that have been accounted for already. Now I have 2 values left. I have a half and I have root 3 over 2. And I want to associate 2 words with these. A half is obviously 0.5. That's smaller than root 3 over 2. That's a little closer to 1. It's a decimal of some kind. Let's call a half small, and let's call root 3 over 2 big. Okay, well, you'll see where we're going with this in a second. Think about pi over 3. Look at pi over 3. Pi over 3 has an x value. Look at where I'm drawing my x. And it has a y value. Now look at these two. Does it have a small x and a large y? Or does it have a large x and a small y? Well, hopefully you said it's got a small x. You see how close it is to 0. But it has a big y. See how high that is. That's the way I think about what the sine or cosine or the x value or the y value of these radian angles are. The x value is the small number, so that would be a half. And the y value is the larger number, that's root 3 over 2. So this point here at pi over 3 would be the point 1/2, that's the x, comma, root 3 over 2. And then likewise, pi over 6, just look at where pi over 6 is. You have a really big x, much bigger than the other one, and a much smaller y. So the large x value would be root 3 over 2, and the y value would be a half. So that helps you construct the point. And that's easy to remember in your head, just as you're trying to visualize the unit circle. Because if you look at this completed unit circle, these that have root 3 over 2 and a half, they flip-flop not only their order, you know, x, y, a half comma root 3 over 2 versus root 3 over 2 comma a half, but at the same time they're also switching signs along the way. So it can get really confusing, so we're just trying to make it as easy to remember as possible. Okay, and then that finishes it up. That's all the angles. They're either an axis type angle, a 45-degree type angle, or one of these off angles of 30 or 60 degrees right here. So let's just try it all together. If you want to pause the video and see if you can finish it out, we can do that, but let's just try to follow all of our logic here. I'll start with the angles first. Again, I hope you can see all that. Let me slide this over in case it's behind my picture-in-picture. All right, this is 0 or 2 pi. If you complete a full revolution, that makes this pi, that makes this pi over 2, and that makes this 3 pi over 2. Okay, now let's try to fill out these intermediate angles here. Let's use the patterns that we know. We know the denominators will always go 6, 4, 3, 6, 4, 3. As we move away from the x-axis, 6, 4, 3, and 6, 4, whoops, 6, 4, 3 as we move away from the x-axis. I remember the first quadrant, these numerators, they all have a pi, but these numerators are all 1 pi. So pi over 3, pi over 4, pi over 6. Second quadrant, the numerator is 1 less than the denominator. So 2 pi over 3, 3 pi over 4, and 5 pi over 6. The third quadrant, the numerator is 1 more than the denominator. 7 pi over 6, 5 pi over 4, 4 pi over 3. And then the fourth quadrant was that funky one where you take double the denominator minus 1. So you have 5 pi over 3, 7 pi over 4, and 11 pi over 6. And that's all the angles. That's it. All right, now let's turn our attention to the points. Now I'm kind of running out of space a little bit here, but I'll do the best I can. Okay, let's do the axes ones first. This would be 1 comma 0, 1 on the x-axis, 0 on the y-axis. This will be 0 comma 1. This will be negative 1 comma 0. That's a negative x value. This will be 0 comma negative 1. That's down the y-axis there. Next, let's do the 45-degree type angles. We remember these are all root 2 over 2. So the first quadrant has a positive x and a positive y. The second quadrant, root 2 over 2 comma root 2 over 2. The second quadrant has a negative x and a positive y. So you notice I said negative root 2 over 2 comma positive root 2 over 2. The third quadrant is a minus minus, so I'll say minus root 2 over 2 comma negative root 2 over 2. And the fourth quadrant has a positive x, that's root 2 over 2 comma a negative y value, negative root 2 over 2. All right, then we have these off angles to finish the thing out. Let's see, we'll do these in maybe blue. How about that? All right, so these are probably the most difficult to remember. This is where we think big versus small. Big versus small have two quantities, a half versus root 3 over 2. Root 3 over 2 is big, a half is small. So let's see here, root pi over 6. Think in your head, is the x value bigger or the y value bigger? Obviously the x value, so we would say root 3 over 2 is the large x and 1/2 is the small y. Now how about pi over 3? Well, that has a small x value of a half and a large y value of 3/2. Okay, how about 2 pi over 3? So right here, I can tell that it has a large y value, root 3 over 2, and a small x value of a half. Now we also have to consider sign. In the second quadrant, the x is negative and the y is positive. So that's what I mean about considering the sign at the end of the problem. Think big versus small, and then after you've written what the numerical values are, then adjust the sign as you need. 5 pi over 6 has a large x value and a small y value, but the x value is negative. 7 pi over 6 will be a large x value, root 3 over 2, and a small y value, but the y value is negative. And matter of fact, the x value is negative as well, isn't it? 4 pi over 3, we have a small x value of a half, a large y value of root 3 over 2, and they are both negative. So I know this is getting crunched. Don't really have a lot of space to write this, but here for the last one, let's just finish this out. We would have 5 pi over 3, small x, large y, but the y is negative. And then last one, 11 pi over 6 has a large x and a small y, and again the y is negative. So we've finished the unit circle. It was completely done. Now once we get pretty good at that, I would suggest maybe going to Google or something and printing off about 5 or 6 blank unit circles and maybe one completed unit circle and just fill them out and fill them out and fill them out until you're pretty proficient at it. Now, what are we going to do with this unit circle now that we're done? Well, I'm not going to spend a lot of time on this in this video, but what we should be expected to do is take something like the cosine of, let's say, 5 pi over 6 and say what that would be mentally in our heads. So I'm thinking, I'm visualizing the unit circle. I'm thinking, where is 5 pi over 6? Well, that numerator is 1 less than the denominator. I say, oh, well, that's in the second quadrant. That's where the numerator is 1 less than the denominator. So I have it pictured in my head. I know roughly where it is, what it's looking like. That's that flatter angle that's closer to the x-axis. And so I think to myself, all right, if that's one of those off angles, does that have the big X or the big Y or the small X or the small Y? Which is it? The X value was the big number because it was so flat, and the Y value was very small because it was very flat. So the cosine, meaning the X value, I'll write as root 3 over 2, and then it would be negative because of the quadrant it's in. That's how we use the unit circle. So I should be able to give you any of these. Let me just end with two last ones. You guys tell me. I'll just make both of these sign problems. What is the sine of 5 pi over 4? And what's the sine of, let's say, pi over 2? Okay, so visualize the unit circle, pause the video if you need to, but the answer is 5 pi over 4, this would be negative root 2 over 2, because it's in the third quadrant, because the denominator is 1 more than 4, and it's negative because of that quadrant, and it's root 2 over 2 because this is one of those 45-degree type of angles. Pi over 2, that's that vertical 90-degree angle, sine of pi over 2 would be 1. So if you're getting these as I'm doing these, then you know the unit circle, and you would be able to answer questions like that one I referred to at the beginning of the video here, as far as what the sine of what angle would give you 0 and cosine of what angle would give you a half. So maybe you want to finish those out, but that finishes up this video. Hopefully you can memorize the unit circle now on your own and do better in your calc classes.